Mark, how Cosmo DB is different than other databases?
So Cosmos is different in a couple of different ways. First is Cosmos is a scale-up database. We're horizontally scalable. So unlike, say, a relational database where you're going to scale up by increasing the size of your VM, in Cosmos, you just keep adding additional nodes or compute or partitions, we call them, and you get additional size in that. And this is great because it does provide unlimited storage capacity, and theoretically unlimited, because you can just keep adding different pieces of compute. The other thing it does too is because each of these pieces of compute can process requests, you get unlimited throughput as well for your databases in Cosmos. The other big difference too for us is Cosmos is non-relational. We don't put locks on your data, so we're not going to lock a piece of data to read or write from it. We don't enforce relational constraints, foreign keys, any of that stuff. And the reason is because we're really designed for kind of that high performance scenario. So we don't want to put locks on data. The other thing too is because we're a scale out, you would have to put distributed locks across these different nodes or partitions, and that's just not good from a performance or availability standpoint. Speaking of which, so because we have this scale out thing, as I mentioned before, so we scale out and add different nodes in there. We call those partitions within Cosmos DB. And so the way you see this is when you create a new collection or container in Cosmos DB is you specify the partition key. And this basically helps us route the data, whether you're writing data or you're reading data. Like here, I've got one that's username of Andrew, partition key of username. So if I want to write data to my Andrew partition, I include that in there, or the Mark one, or the Tim there, or the Tim one there. And then on the read path, it's important then I want to use that partition key when I'm trying to find my data. So here I've got this query, select star where C username equals Mark, and that's our partition key. So when I pass in that value, I know exactly where to go and get the data. And this allows you to write really high performance queries within Cosmos DB. So that's kind of the big difference, is that horizontally scalable and non-relational.
Oh, okay, so now I know why it's different, but why would I care? Why should I pick Cosmo instead of something else?
Sure. So that kind of horizontal scalability allows us to have a high amount of elasticity with your throughput, right? Because we can just keep adding nodes and adding more throughput, more storage to your account. In fact, we can do this with no downtime. So you just increase the throughput on there. We'll go behind the scenes and increase the amount of storage and throughput that you can handle within there. We're also a regional or multi-region database. So we can replicate data into any region in Azure and then make that available to serve reads. And we do that and maintain the consistency of that data across any and all regions. The nice thing too is because we're multi-regional, we can survive regional events. So we can provide higher availability than, say, if your database was just running in a single region. Also, even within a region, we have multiple copies of your data. So we have what's called a replica set in Cosmos, and we write your data 4 different times within that region. We maintain a quorum over that data. So we'll maintain a 3-quorum, replica quorum for that data. So if one of the replicas happens to have an issue, that's okay. We can maintain the availability and still read and write data in and out of your account while we get another replica filled in its place. Lastly, we can also co-locate these in availability zones, which is great because now you can survive, say, a zonal outage if that happened within a region as well. So we're really built for kind of that elasticity, that availability, and that high write volume within for workloads.
Very interesting. Okay, so now we know why we should care and everything. Could you help us, like by giving us, like in 2 minutes, or about different scenario where like Cosmo DB will be a good fit?
Yeah, of course. We see lots of different workloads where they want one of those 3 different characteristics, whether it's the elasticity, the availability, or that high write volume. IoT workloads is a good scenario where we're ingesting large volumes of device telemetry. And that's great because you can just provision more throughput and ingest more and more data. Another one is e-commerce, and they love us because of that scale, because they can quickly scale up if they need. Also, e-commerce, they really value availability, right? Like there's nothing more painful or costly than if you can't sell anything. So having a database that can maintain high availability is important for them. Manufacturing is another one. They use us for parts list, supply chain, financial services, particularly payment processing is another huge scenario for us, both from elasticity and scale and availability. Anything where a document would make sense for storage is a workload that we see usage. Also, workloads where maybe the schema is quickly evolving, or maybe where there is no real schema. Are workloads where you see people using Cosmos.
Yeah, because of that flexibility, it's easier to adjust.
Right. We don't. So that's that fundamental difference of non-relational. We don't enforce schema at the database level. You enforce it at the app level.
And also, there's many different APIs. So, like as a developer, like I could use many different way to communicate to Cosmo DB. Am I right?
That's correct. We're multi-model, so we have our own core, what we call SQL API. It's a SQL flavor over JSON data. But we also have support for MongoDB, Gremlin, Cassandra, even the old table storage. We have support for that as well.
The old.
The old. It's been around for a long time.
Yeah, I know what you mean, but just, it's
the old. Sorry, I don't mean to disparage my table terms.
But okay, perfect. Thank you. So you know what? Let's see what the chat has for a question. Thank you for your time.
You bet.